1.1 Scalars and Vectors. There are two kinds of measurements in physics. Measurements where direction does not matter. And measurements where direction is important. It's critical to giving the measurement meaning. Up until now, you've mostly been used to using the first kind, where direction isn't important. This first kind of measurement, where direction does not matter, is called a scalar quantity, or a scalar measurement. Measurements where direction is important are called vector quantities, and they're going to become very important in physics in the upcoming months. Examples of scalars include mass, time, length, and speed, which makes sense because if you have a 5 kilogram mass, it's not like you have a 5 kilogram mass to the north, you just have 5 kilograms. Examples of vectors include velocity, which is how fast you're going and which way you're going, acceleration, which matters which direction you're speeding up in, and force, which matters which way you're pushing and which way you're pulling. For questions with vectors, or with scalars, your answer must have the following pieces. It must have correct magnitude, so it must have the correct amount or number to get full marks, and it must provide a unit. And this magnitude must also have correct significant digits. For example, the measurement d equals 15 meters, or distance equals 15 meters. The magnitude is the number 15 with 2 significant digits, and the unit is the meter. Both pieces are important for a correct answer. For questions with vectors, you have an extra piece. You have the direction piece, and your answers must have all 3 pieces to be correct. These are magnitude, which is the amount or the number part of the answer, the unit, and you put direction in square brackets to show which way the vector is pointing. Your magnitude must also have the correct significant digits. An example of a vector written out is the store is 150 meters to the north. The magnitude is the 150 meters, the unit is the meters, and the direction is the north in square brackets. On your data sheet, the symbols for vectors and scalars are differentiated with little arrows over the letter. This allows us to tell which kind of symbol shows a vector and which kind shows a scalar, and it tells you what to do in your calculations. For example, v is speed, which is a scalar quantity. The same letter v, but with an arrow over it, indicates instead velocity, which is a vector quantity. Calculations with vectors and scalars use different techniques. If you have a vector, you have to do one kind of addition technique, and if you have a scalar, you do the other. Adding scalar quantities together is actually quite easy. It requires no new skills. You can just add the numbers together. Vectors, on the other hand, require a vector addition techniques. Vector arithmetic, or adding vectors, is a bit more tricky. This is because you also have to consider the direction in your calculation. For now, we're only going to worry about one-dimensional vector addition. Later on, you're going to learn how to add two-dimensional vectors and possibly even three-dimensional vectors. But for now, our vectors are always going to be in the same plane or pointing the same or opposite directions, which is one-dimensional. The first method for 1D vector addition is to draw a picture using vector arrows. So you draw arrows to show the length and direction of the vector, indicating size and direction. You line up the tip of one arrow with the tail of the other. This is called tail to tip or tip to tail vector addition. It's not as hard when it's only one-dimensional and it seems quite simple, but it's a good technique to learn now while it's simple, so that way for two-dimensional vector addition, it's already something you understand. So for example, 15 meters east plus 25 meters to the west. We draw the 15-meter arrow pointing in an east direction, and then from its tip, we draw the 25-meter arrow to the west, and it's longer to show that 25 is longer than 15. The answer goes from the tail of the 15 to the tip of the 25, and just by eyeballing it, we can see that it's 10 meters to the west. This final answer is actually called the resultant, and this answer is found by drawing a resultant arrow from the tail of the first vector to the tip of the second. The second method for vector addition is to use plus or minus signs to indicate direction, in your calculations. The direction signs can be told by looking at our Cartesian coordinate plane. This is something you should be familiar with from math. Now, north is the direction that's up and south is down, east to the right and west to the left. We can also say east is a forward direction and west is a backward direction, for now. North and up are positive. South and down are negative, just like the positive and negative y-axis. East, right, and forward are positive. West, backwards, and left are negative. Here's an example. 125 meters to the north plus 95 meters to the south. We'll start by writing out the question again so I can show you how to use the plus and minus sign instead of directions. Cross out the direction and replace it with the corresponding sign. So north becomes positive and we have positive 125, and south becomes negative and we have negative 95. The answer is positive 30, but this is not proper vector notation. To get the proper vector notation, we always have to change the plus or minus sign back to a direction. Since we were working in a north-south direction before, we assume that the positive direction indicates a north. And we also give it a unit of meters. So we have 30 meters to the north as a final answer.